Hey, seventh graders. So we're continuing on with the expressions part of things this week, and we're going to bring something back that I am quite certain that you learned about through elementary, but we're going to see how it works when variables are involved and how it helps us simplify expressions and continue to work with equivalent expressions. I even threw some of these problems in at the beginning just to prove to you that you really have worked with this before. So what is this thing that I'm talking about? Well, you need to get out page 21 in your math binder, get a pen, pencil, something ready to go, and watch with me and take notes with me. All right, we are going to start off with a review on the top of your paper. You can find these examples. You see these three exact examples on your paper. This is what we have been working on all of last week, simplifying expressions. So by way of review, just look at a couple more examples with me, make sure we really got this. So here's what I see, a positive 5x and a negative 12x. Hopefully we can all see directly in front of it as a negative. So what I have here is different signs, subtract, take the sign of the one that goes farther. So those two simplify to negative 7x. Then I have negative 3. Do you all recognize that that's a negative? Negative 3 and positive 9. That's different signs, subtract, take the sign of the one that goes farther. And that's all we can do. We do not combine those because one has an x and one doesn't. So that's what we have, is negative 7x plus 6. We simplified the expression. We also learned, hey, I can do this with fractions too. So this is an x and this is an x, and they need to be combined. So I need common denominators here. So let's focus just on this part for a moment. 5 and 3, ooh, that's going to be 15, right? So 1/5 is equivalent to 3/15 x. 2/3 is equivalent to 10/15 x. Common denominators, right? If I times by 3, times by 3, times by 5, times by 5. Now this is a positive 3/15 and this is a negative 10/15. So I'm dealing with different signs, subtract, take the sign of the one that goes farther. Different sign, subtract, take the sign of the one that goes farther. And then I have plus 1/2. 1/2 does not have an x on it, so guess what? That is simplified. That's as far as I can go. All right, one last problem for review here. Please remember that this is really a negative 1x. That coefficient of 1 is always in there. So I have negative 1x plus 2 1/4 x. Okay, now I could go through making it improper and getting a common denominator and all that. This one probably would be better to just kind of think through number sense here. They are different signs, so I'm going to subtract. I'm going to take the sign of the one that goes farther. 2 1/4 is bigger than 1, goes farther than 1. So 2 1/4 minus 1 is 1 1/4 x plus 1 2/5 y. 1 is x's and 1 is y's. That's it, simplified. So that's what we've been working on, is simplifying expressions, which we also call, you'll often hear it called in mathematics, combining like terms. Simplifying expressions is more officially the name of it, but combining like terms is kind of how you go about it. So one more thing we need to bring back to our memory. So we have to put this together with this knowledge here. Okay, so this is the type of math problems. Actually, you've done these since 3rd grade. You may not remember. That's okay. It's normal to forget things. But I'm going to bring some math language back to you and make sure we do remember what it was we were doing here, because it's a very important mathematical idea. So here's what it says up here. Suppose you want to buy 3 notebooks that are $5 each and 3 packages of pens that are, my face is in the way of that, $6 each. Not for you, but for me. 3 packages of pens that are $6 each. Let's calculate the total cost in 2 different ways. Okay, so one thing we can do is we can calculate the 3 notebooks and the 3 pens separately, and then after we calculate those, we'll add them together. Let me show you what that looks like and make sure you write all this down. So 3 notebooks would be 3 times 5. Because the notebooks are $5 each, plus 3 packages of pens that are $6 each. So this is definitely one way that we can calculate this. We're going to calculate the cost of the notebooks and then calculate the cost of the pens. So we're going to multiply first, because that's what PEMDAS says. If I set it up like this, I'm going to multiply first. 3 times 5 is 15. And 3 times 6 is 18. And now we're ready to add. 15 plus 18 gives us a total cost of $33. So that is definitely one completely valid way to calculate that problem. Okay, let me show you another way. The fact that we have 3 of each of these things, we have 3 each of the notebooks, we can consider it and 3 of the pens, because this number is actually the same. What we can do is we can say, all right, well, I'm going to get a total cost of notebook and pens. What? Not that. Got 3 in my brain from all this work we're doing. It's $5 for a package of notebooks and $6 for a package of pens. So what I can do is I can multiply all of that by 3. The only reason this works is because it's 3 of each of them. If I had a different number here, it wouldn't work. But watch this. Now, if I'm doing PEMDAS, I'm doing my parentheses first. So 5 plus 6 is 11. And now I'm going to multiply that by 3. And would you look at that, I still get $33. So the interesting thing here is I can either multiply them each by 3, each, that's important. I can multiply them each by 3 separately and then add it up. Or I can get the sum first and multiply the sum by 3. Does this look familiar to you at all? Let's see if giving a name to it helps bring things back to your memory. So it says fill in the blanks. The 2 expressions above are, here's that fancy math word, equivalent. Equivalent means the same mathematical meaning, same mathematical value. The 2 expressions above are equivalent because they came out with the same answer. This is called what we saw up here, this idea of I can multiply them separately by 3 first and then add them, or I can get the sum and multiply the sum by 3. That is called the distributive property. Does that sound familiar to you? Let me just show you in this blank space down here how you used it back in 3rd and 4th grade and those elementary grades between. And this is an important thing to note. If you were doing something like 3 times, well, I'm not going to use 3 again. Oh gosh, I just want to write 3 on everything today. So let's say I do 7 times 43. And you might think, okay, I don't really have that memorized. That's not really in my multiplication chart brain. So what you can do is you can break it apart and you can say, this is really 7 times 40 plus 3. This goes back to all that place value work you did in elementary. And you can say, okay, now I can actually go 7 times 40 plus 7 times 3. As long as you take this number that was multiplied in front and you make it a product on both, then it's totally fine to multiply them separately first and then add. Now right here, if we just added them back together, some of you are like, but those are in parentheses, just add them. Well, that just takes us right back to the multiplication problem we didn't know how to do in our heads anyway. Can you type this in a calculator? Yes. But if you're trying to do something in your head, and I do this all the time at the grocery store, different places, if I'm trying to do multiplication in my head, I use distributive property to break it up so that I can say, oh, this is 280 plus 21, and now that's really easy to add. It's 301. Okay, so this is how you've used distributive property in the past, but the idea is that you can either multiply this one number separately to each of the factors and then add it, or you can do the sum first and then multiply. So it changes the order of how you do things, but it doesn't change the result, which is why we made it a mathematical property and said these things are equivalent. So let's put it, here's this big box right here. We're going to put it in algebraic terms because this is a lot more helpful to us. If I have some value, I was using 7 over there. I'm going to call that a variable because we do this in Math 1 when we want to make a general rule. Okay, I'm going to say A times B, and I'm just changing colors a lot because I can and I want to. You can too if you'd like. I'm just going to make all these letters a different color and then the math operation symbols in black. If I have some number A and it is being multiplied by a sum of B and C, the product of A and the sum of B and C. Okay, here's how it looks. That's how it sounds. If I have some number A multiplied by the sum of B plus C, this, I can work it this way, or I can say this is equivalent to A times, and I don't even need the times symbol. I just need to put them next to each other. If I see this in mathematics, two variables right next to each other, I know that's multiplication, okay? This is equal to A times B plus A times C. Notice what has to happen twice though. The A has to happen twice. And when I say happen, what's happening? Multiplication is happening, okay? This is the property that we're going to use to rewrite each of these, use the distributive property to write a second expression that is equivalent to the given expression. So it's going to look different, but it's actually going to be equivalent. So here is what I want you to do. I want you to label on this expression here, just right underneath it. I want you to tell yourself that now 2 is like the A up here. X is like the B, and 3 is like the C. All right, so we've got this 2 in front, so what we need to do, and I'm going to use red that doesn't match any of these other colors so I can show you what I'm doing. Actually, you know what? No, I'm going to stick with my color scheme because it's fun for me. So I'm going to say if I have this sum, now here's where distributive property is really helpful to us because I actually couldn't evaluate this either way because I don't know what X is. So I certainly can't do X plus 3 anyway. So I'm just trying to rewrite it and get a different expression. So here's what I know from up here. That means I need to do 2 times what? 2 times X. See that? I'm going to do 2 times X plus what has to happen again? The A. Do you see how the A, this green letter, happens twice? That means the 2 has to be multiplied twice. You better write that A value twice. In this case, it's a 2. So I'm going to have 2 times X plus 2 times, you ready? 2 times what? 2 times 3. And now we just need to clean this up. Okay, all right, we could leave it with the parentheses and everything, but a mathematician would simply write 2x. You can take away all the parentheses. We know that means multiply, but so does that. And that second one's easier to write. And this one, oh, we know that 2 times 3 is 6. Is there anything else I can do with this? No. I have 2 x's and 6 1's. I can't put them together and call it 8 x's because I don't have 8 x's. I only have 2 of them. So this is as far as I can go. But the main idea here is you just use the distributive property to write an expression that is equivalent, even though it looks different. This expression right here, 2x plus 6, is completely equivalent to this expression that we started with. Okay, if I took a value of x and plugged it in, I'd get the same answer. Watch, if I plug in, let's say I tell you all of a sudden x is 10. Well, on this one, you do 10 plus 3 equals 13, and then 13 times 2 is 26. Well, if I plugged it in right here, you do 2 times 10 first, which is 20, and 20 plus 6 is 26. They are equivalent because no matter which x value I pick, they will come out with the same answer. All right, let's try this again. This time, our A value is 8. All right, so I need to do 8 times -2 is like the B value here. -2. Oh yeah, you know those signs are always going to come back. Those positives and negatives. We can't ever forget how those work. Plus 8. Look, the green one is happening twice. Yours might not be green on your paper, but the A value needs to be multiplied twice every single time. Okay, and then we're going to have 5y. That whole thing is its term. And that whole thing needs to be multiplied by 8. So the distributive property is telling me whatever number is multiplied by the sum, you need to multiply it separately by each term. I'm going to do 8 times -2 and 8 times 5y. And now I'm going to clean this up. 8 times -2, different signs, the product is negative. So this is -16. Then I have 8 times 5y. 8 times 5 is 40, and that y was just being multiplied. I can't actually multiply because I don't know what it is, so it just stays stuck on the product. So this is 40y. Do I put those together? Absolutely not, because they are not like terms. One has a y and one doesn't, so this is all we can do. This is writing another expression that is equivalent to the one we started with, even though it looks different. My pen is on a lag, and that makes it really hard for me to keep track of what I've drawn and where I am, and it makes me draw really weird big boxes. I have stopped drawing a long time ago, I feel like, but that pen just kept going. All right, let's try this again. Number 6. This one doesn't have any variables, but it doesn't matter. The idea here is that we are going to, and I think with my pen lagging, I can't switch colors 1,000 times, and that's okay. That's fine. You guys get the idea now, I think. So let's find out. Let's try it. Here we go. I'm going to do A times B plus A. Oh, that's not A. Which one's A? 3. 3 is the A. Okay, so I'm going to do, I have A times B plus A. That A has to happen twice. Times C. Now be careful. A mistake students make here is they always just want to put the 7. Is that a 7? No, that is a -7. Do you all see that? Those signs are really, really, really important here. Okay, so now I'm going to clean this up. 3 times 5 is 15 plus -21, or I could just write -21. Could I evaluate that? Yes. Do they want me to? No, it doesn't say the word evaluate. It just says make an equivalent expression. I did. Okay, but the whole idea is A times B plus A times C. This is the distributive property, and this is how it looks when you have variables. All right, I want you guys right now to just pause the video and try this next row. Be careful with your negatives. Try 7, 8, and 9. And once you've finished those 3, we talked about this in the last videos. When I tell you to pause and try it, it really is better for your brain if you do. If you want to switch and use a pencil so that you can erase and fix things if you need to, that's fine. But it's a really good part of the learning process to make some mistakes first. Pause the video, give these a try, and then come back and see how you did. Okay, I've got the first step set up for you here. This part is, I'm going to say it out loud, A times B plus A times C. Check that out right there. Did you make that a negative? If not, fix it right now. A, ooh, look, the A this time is a negative. We have to be very careful with that. A times B plus, I always still just write the plus. I'll take care of the signs when I'm done, but the original format is there's a plus here, but the A is negative. So see how I wrote -3 here? I have to write -3 here as well too. The A just gets copied twice. A times B plus A times C. Here, lots of negatives on this one too. A times B plus A times C. So if you're looking at this and you're realizing is not a word, realizing that I forgot some negatives in a couple places, that's okay. Fix it right now. Pay attention to where I put the negatives and why. Do you see how that -2, I moved that there? That's a -5, so I moved that there. This really helps us keep our signs straight. So now I'm ready to clean these up. These are not done. Now I'm going to do whatever multiplication I can. 5 times 2x is 10x. 5 times -4 is -20y. Could you write plus -20? Absolutely, and that would be equivalent. But as we talked about all last week, more efficient mathematicians will just, if it's negative, they'll make it a minus. Just because it's faster to write, no other reason really. Okay, right here, different signs, negative. Right here, same signs, positive. Double check what you got, and if you need to fix anything, by all means fix it right now. And if you're looking at it like, I don't understand how you got that, Miss McGowan, ask me, either in real life or through messages or whatever, and I'll answer it either way. So here, different signs, negative. Same signs, positive. I also want you to notice on all of those, that green step is it. That's done. That's all I can do. Not like terms, not like terms, not like terms. So I can't put anything else together. All I was doing was using the distributive property to get an equivalent expression. I'm going to take you through a think aloud now to finish off these last few examples. And this is where you're going to practice on your Canvas quiz. And this will help you. We'll bring this back together with simplifying expressions over the next couple of days. So here I go. A times B. Watch your signs here. Plus A. Do you notice this is a -2? So there's A times C. I'm going to do the first step through all of these. Whoa, this has like A times B plus A times C plus A times D. That's okay, just keep it going. Ready? A times B plus A times C plus A times like another one, D. This can go on with for as many terms as you need to, but if you have a sum inside those parentheses, every single one of them needs to get multiplied by that A. Every one, doesn't matter how many there are. So let's try it again right here. A times B plus A, wacky pen, times B, I mean that's C technically, plus A, ooh, look at that, be careful right there, that's a -3. The number one mistake students make with this, you guessed it, the signs, the positives and negatives. So let's clean these all up. 4x squared, different signs, -8. All done, those aren't like terms. Different signs, negative. Same signs, positive. Different signs, negative. Are any of those like terms? A, B, nothing? Nope, can't put any of them together. All right, last one, let's clean it up. Different signs, negative. Different signs, negative. And same signs, positive. Distributive property. It's something you learned in elementary and we're still going to use it a lot. So give your practice a try. If you're confused on anything, please let me know and I would love to help you.